Hello, hello. It is I, Mr. Swearingen, back again with our last lesson in this unit. Not 8.6, 8.5, in which we're really doing the same exact thing that we did in 8.4. That multiplying binomial stuff that we learned, same exact stuff. There's only 4 examples. If you got a good grasp of what it's like to multiply binomials, this will be a walk in the park. So here, let's just remember real quick, when multiplying a binomial with a trinomial, we'll use a process called double distribution. Double distribute. Same process. What that looks like is if I have a binomial, now instead of multiplying it by another thing with 2 terms, I multiply it with something with 3 terms. Maybe something that looks like this. But it won't change our process. What does this mean again? I'll just say here that we distribute twice. Let's just get straight into it. And I'm going to teach you a trick today to help keep our work and our thinking organized. So I'll explain that here in one of our later examples. But look forward to it. I love it. I think it's really nice. We only have one extra step. But let's start in with what we did last time. We take the first piece, this 2x, and we distribute it. So we're doing like 2x times 7x squared. Oops. We multiply our coefficients, so 2 times 7 is 14. And then we add our exponents, so we have that invisible 1 plus 2, giving me x to the third. Then we do our next piece, 2x times negative 5x. We multiply our coefficients. 2 times negative 5 is negative 10. We add our exponents. 1 plus 1 is 2. And we do this last piece as well. What's 2x times 2? Well, we multiply those coefficients. We get 4. There's nothing to multiply our x's by, so we're just left with that x. And that's the first distribution. No new processes, no new crazy things to think about. We're just doing it one extra time. And the same thing with the other one. We take this positive 3 and we multiply it. 3 times 7x squared, multiply the coefficients to get 21x squared. Ooh. I'm having to move things around. 3 times negative 5x, multiply those coefficients, and you will get negative 15. And then we'll just carry the x. And finally, we'll multiply 3 times 2 to equal 6. Once again, same distribution process, we just do it one extra time. Now that we've done that, let's find our like terms. So let's, oops, accidentally turned it off. So it's getting kind of cluttered, isn't it? There's a lot of terms we're looking at now. So let's ask ourselves this. Here I see a 14x to the third power. Do I see any other third powers here? No. Nope. None other have the power of 3, so that will just copy down. Boom. Then I see something with an x squared. Do I have anything else that's x squared? Here, this 21x squared. So I combine those. Negative 10 plus 21 is going to give us a positive 11x squared. Good, I dealt with that. So next, I move on to this this 4x, my exponent of 1 now. Is there anything I can combine this with? Sure enough, I see this minus 15. 4 minus 15 is going to end up giving us minus 11x. Good. And then it looks like the last thing I have is this plus 6. Once you combine all the things you see that can be combined, ask yourself, is this in standard form? Is my biggest exponent here? Is my next biggest exponent next? So on and so forth. Here we got it, and we're good to go. That's it. So in this next example, I'll show you the trick. It helps avoid stuff like this. Now that we're getting a lot of stuff all in the same line, it can get easy to get confused, to not see things that we would want to combine, to accidentally combine the wrong things. So this trick we call stacking helps keep it all organized. So let's go back to that. What color would you call this? It's like a salmon-y pink. Let's start with our distribution. 2x times 3x squared. Multiply the coefficients to get 6. Add the exponents to get 3. So far, nothing's changed. 2x times negative 4x. Make sure you're bringing in that negative. 2 times negative 4 is negative 8. We add the exponents to get x squared. And then we do 2x times 8, which is just 16x. So far, nothing's different. But when we do the second distribution, this is where our stacking comes in. So here I have a minus 6. Minus 6 times 3x squared. Well, we multiply those coefficients. Negative 6 times 3 gives me negative 18x squared. Instead of writing it off to the side like this, we're going to stack it underneath the same degree term. So, oops, accidentally erased too much. So, do you see here how this x has a squared exponent, has an exponent of 2? When we stack it, we will stack it underneath the term that has an exponent of 2, which is here, that minus 8x. So what I'll do is I'll put this minus 18x squared right underneath, and I'll keep going. Negative 6 times negative 4x. Remember, negative 6 times negative 4, multiplying a negative by a negative gives a positive. So that's plus 24x. And then negative 6 times 8 gives me, oh shoot, my multiplication facts here are not my best. Minus 48, I believe. Where would I stack this? It's just 48. It doesn't have any x next to it. So it won't stack here, it won't stack here, and it won't stack here. That just means we put it off to the side. Minus 48. Anytime we have a new x, oh my word, That eraser is huge. We'll just leave it. Do you see how this looks a bit nicer? There's not as much, well, let me erase all my marks. There's not as much clutter. It's not just one string line like it was in this past example. So what we do here, once we stack, we just add the columns. Well, 6x plus nothing, we just bring it down, 6x cubed. Negative 8 and a minus 18 gives us minus 26x squared. 16 plus 24 gives us 40x. And 48 plus nothing, we just bring it down, minus 48. Stacking is really nice because then you don't have to search for your like terms. They're already grouped together nicely in a column that you just have to add. Is this in standard form? Yes, it is. So we're done. Bravo. Here's what I'm going to say. For example 3 and example 4, I'll have you try these on your own. So go ahead, starting with example 3, take a couple minutes, work it out, and then I will work it out here in a couple seconds, really. Here we go. Okay, starting with this 8x. And I'm going to stop, I'll put my workout to the side one more time. 8x times 4x squared. We multiply the coefficients, 8 times 4 is 32, and we add the exponents. Now we do our next piece, 8x times x. Well, the coefficient just carries, 1 plus 1 on our exponents gives us 2. Finally, I'm doing 8x times 5. 8 times 5 is 40. And then we have that lonely x. So far, so good. Maybe? Then, here's a trick. Do you remember to think of this as a negative 3? Negative 3 times 4x squared. Well, negative 3 times 4 is negative 12. Keep the exponent. Here, because it's an x squared, I will stack it underneath the 8x squared. Negative 3 times x is negative 3x. Because it's just a plain x. Oh, and you know what? It looks like I forgot to put my x on my 40. So I'll correct that real quick. Finally, I will do this negative 3 times 5, giving me negative 15. Since there's nothing to stack it under, I'll just write it off to the side. Now I will add my columns. 32x to the third minus 4x squared plus 37x minus 15. That's my final answer. How'd you do? If you didn't get it, try to find your mistake. If you're having trouble, find a time to ask me, email me. Happy to help. Same thing. Take a minute, do this last one on your own, and then chime back in. Unpause and work it through in 5, 4, 3, 2, and 1. Take this 6x, ciao. I'm not going to put my work off to the side this time. 6 times 4 is 24, and then I add my exponents. 1 plus 2 gives me x to the third. Then I do 6x times x, which will just be 6x squared. Then I do 6 times negative 5, giving me a negative 30x. Finish up with that last distribution of positive 4. 4 times 4x squared, well, that's going to give me 16x squared. Then I'm going to do 4 times x, giving me 4x. And finally, 4 times negative 5, which is negative 20. There's no place to stack it, so I'll just write it off to the side. Then we add our columns. 24x to the third plus 22x squared minus 26x minus 20 is our final answer. There you go. How'd you do? Hopefully some things are clicking together, working well. Once again, if you have questions, please, please, please let me know. But this has been 8.5, Mr. Swearingen, signing out. Just right before I do that, there are 8 problems for you to do for your practice. Goodbye.